Hi, in this presentation we're going to look at the economics of insurance. Suppose we have a golfer with the utility function U equals the square root of W. W is going to represent the golfer's wealth. The golfer will earn $1 million if healthy, but there's a 10% probability that the golfer gets injured and will earn nothing. So let's answer some problems here. Let's start with a clean slide. Utility equals the square root of wealth. We want to find expected utility first. Expected utility equals the probability that the golfer is healthy, the probability the golfer is healthy, multiplied by the utility of healthy. This then is going to be added to 1 minus the probability that the golfer is healthy, which is just the probability that the golfer is injured, times the utility if injured. So in our problem, there's a 90% probability that the golfer will be healthy. So that's 0.9. If the golfer is healthy, he will earn $1 million. Let's evaluate the utility function at $1 million. Okay, so that's the first part of this. The next part is there's a probability that golfer will be injured, which is just 1 minus 0.9, or as we said in the previous slide, just 10%. And the utility if injured, well, if injured, the golfer earns nothing. So wealth is 0. And if we were to solve this, we're going to get 900. So the expected utility for the golfer is 900. Okay, let's answer another question. Let's find the actually fair insurance policy. The actuarially fair insurance policy. Okay, we can assume full coverage here. That is, if the golfer gets injured, his insurance policy will pay him back the size of his loss, which is $1 million. So an actuarially fair insurance policy is just going to be the probability of loss times the size of the loss So in our problem, the probability of the loss, in this case the golfer is injured, is just 10%. The size of the loss is that the golfer loses $1 million. So an actuarially fair insurance policy would charge this golfer $100,000. The golfer would pay an insurance premium of $100,000. If the golfer got injured, he would get $1 million, the size of his loss. Okay, let me go to a clean slide. Next question we could answer is, suppose the golfer does buy a full coverage insurance policy at an actually fair premium. Okay, so let me repeat that. Suppose the golfer were to purchase a full coverage insurance policy at an actuarially fair insurance premium. What would be his expected utility? Okay, so we want to find the expected utility if the golfer were to get insurance coverage. So let's do the following. If the golfer is healthy, he's going to earn $1 million. But we're going to assume he bought an insurance policy that he paid $100,000 for, an actuarially fair policy. That would leave him at the end of the year at $900,000. If the golfer gets injured, he won't make any money, playing golf, so that's 0. He still has to pay the premium, but the good news is he gets back the size of his loss, which is $1 million. I'll just write 1 mil. Okay, so that's the insurance reimbursement. Insurance reimbursement. So here, doing the math, he's left with $900,000. So regardless if he's healthy or injured, the golfer's going to have the same amount of wealth at the end of the year. Let's calculate his expected utility with insurance. So expected utility with insurance. Okay, so there's a 90% probability that he'll be healthy. How much wealth will he have? $900,000. Okay, we're plugging $900,000 into that utility function. Remember, the utility function is just the square root of wealth. That $900,000 is coming from up here. There's a 10% chance he'll be injured, in which case the insurance policy will kick in, giving him $1 million, but after subtracting the insurance premium, he'll have $900,000. Taking the square root of that, just evaluating the utility function at that, we're going to be left here with 948 point, rounding up to the nearest tenth, 0.7. So one thing to note here is that this golfer is risk averse. This golfer gets a higher level of utility from a guaranteed $900,000 than facing a gamble or a risk with an expected value of $900,000. Okay, so this is what it means to be risk averse. Okay, one other question we could look at is something about maximum willingness to pay. What is a golfer's maximum willingness to pay for full coverage insurance? Okay, let me do this on a clean slide. Okay, so we're looking at maximum willingness to pay here. Oops, maximum willingness to pay for full coverage insurance. It's best if I present this in a graph, and then from there that'll help inform our math. So we'll put wealth here, utility. Here's a utility function for the golfer. Yeah, that's $1 million there. This is going to be the expected utility cord. Should connect to 2 dots. This is going to be 900,000. We found this value here at 900. That's the expected utility of the gamble. The gamble being there's a 10% probability you'll get injured. And then we calculated the utility here if you were just guaranteeing yourself $900,000 a year by buying a insurance coverage at an actuarially fair premium. This was 948.7. This is going to be the crucial value in the maximum willingness to pay. I'm going to try to find this W star here. Okay, and the maximum willingness to pay then will equal the following. It's going to be 1 million. It's going to be whatever this value is here minus W star. So how do we get W star? Well, our utility function looks like that, and we're going to plug 900 into the utility function. And we're going to solve for W. Squaring both sides, we get 810,000. That's our W star in this case. Plugging that into here, 1 million minus 810,000 gives 190,000. That is the most that this golfer would pay for an insurance claim that would cover his $1 million, an insurance policy that would cover his $1 million loss. And you'll notice here that that is the most he would be willing to pay. And as I said, that's 810,000 now, right? That value W star. Notice that he would get the same amount of utility going into the year facing the gamble. He could be healthy, he could be injured, or he could guarantee himself an income of 810,000 if he paid a policy of 190,000. Okay? So that is the economics of insurance.